I often get asked, where would you use 3D arrays? So this is a perfect example of using 3D arrays. Let's say you're trying to track weather information for multiple locations. So in this example, I just have 2 locations, but you can imagine more than 2. And then here, what we are trying to do is we're trying to track the time as well. So this could be 10 in the morning, 11, and so on. So what we are trying to do then is for that time period, also record multiple items. So such as the temperature, humidity, and pressure. So this is the temperature, humidity, and then pressure. And you can see the same thing for location 2, time 1, time 2, time 3. So this is quite an interesting situation for a 3D array because you're tracking the location, the time, and then the individual items such as temperature, humidity, pressure, and you can add more if you need to. So notice here that I'm using the Numpy library, and what the Numpy library allows us to do is create a 3D array. So the Python array module doesn't really let us do that, but Numpy does. And then here I'm just trying to do the shape. So if I were to run this, what do you think we will get the output here? So if I run this, and you can see that, or this element here, where we are trying to do location 1. Remember, this is 0 index base. So 0 is the starting point, but that is number 1 location. And then this is number 2 location, for example. And after the comma, we are specifying the time. So this is now number 1. So this will be this one because this is 0. And then this is 1. And this is 2. So here you can see we've got 26.1, 67, and 1011. So this is the output that we get from here. And the code for it is we just simply specify 0 and 1 because we want the first location, and then we want the second time. So then here you can actually print an individual element. So this is now you want for location 2 because again it's 0 index based, and here we are going with the third because again it's 0 index based. So this would be the third time here, but this would be this one. And what we are trying to get is the first element at position 0, 32.5, or here 32.5, and that's the output we got. This is a simple case of where you would use 3D array for storing the weather information. And remember to use the Numpy module because that will allow the creation of 3D arrays. And that's all I wanted to show you. So hopefully you found a good explanation of when to use and how to use a 3D array. Do you know what a 4D array looks like? Well, this is a practical example of what a 4D array looks like. So again, here we're using the Numpy module to create this 4D array. And this is how the dimensions of that 4D array look like. So here, really what you're trying to do is store multiple pieces of information and access them in an orderly fashion. So here you can see what we are trying to do is store temperatures, humidity, and pressure for 10 cities over 7 days and over 24 hours. So why the code 4D array? Because it's got 4 dimensions, 1, 2, 3, 4. We've got number of cities, number of days, number of hours, and number of parameters. So here, what we're doing is we're generating the 4D array because there's too much data to manually type. So we're just going to generate the number of cities, which would be 10, number of days, 7, number of hours, 24. But for the others, what we are doing in terms of temperature, humidity, we're just going to generate some random numbers here. And then we're going to print the shape of the array. And then we're going to try and get a temperature for a certain city. So if I run this, so as you can see here, this is the shape of the array. So it's got 10 cities, 7, 24, and 3 values for the weather. So here we've got temperature, humidity, and pressure. So what we're going to do here is to access the value for city 3. Remember, it's 0 index base. So this would be 2. So 3 minus 1 should be 2. We're going to access it for the 5th day. So again, minus 1 takes us back to 4. And then we've got the time, which is 14. And the temperature, which is over here. So you can see here, this is how he would access the 4D array. And now you can see here, we get the temperature 25.72. So this is a practical example of what a 4D array looks like. You've seen 3D arrays. So what would a 3D array look like? Well, 3D array would simply be just you would have to discount, for example, you could track different locations. So it could be 10 locations and number of hours and parameters, but you then miss out the number of days. But this is actually going to do it over 7 days. That's why this is a 4D array. So you can store more information than you can do on a 3D. You probably have seen 2D array, 3D array, and maybe even 4D array in my previous video. But you always wondered whether, what can you use 5D array, 6D array, 7D array, or 9 or 10D array. So in this video, I'm going to talk about all those additional dimensions and what you would use them practically for. So here, let's say you are storing the temperatures, humidity, and pressure for 24 hours, for 7 days, and let's say you're doing it for 10 cities. Then another dimension that we would add is the number of countries. So these 10 cities across 5 different countries, for example. This is what is known as a 5D array. And as you can see here, we are capturing additional dimension here of countries array. So 6D array would be you capture something above that. So which is number of continent. And you could have a continent, for example. And then within those 5 countries and 10 cities and 7 days and 24 hours and 3 different type of measures we are using. So temperature, humidity and pressure. 7D array. So 7D array is another layer on top of that. So you're capturing the continent. What about the hemisphere? Here you've got northern, southern and eastern and western. So you would capture additional level on that, and this would be stored in a 7D array. And then your question might be, well, where would I use a 9D array? So let's have a look at that. So 9D array would be used in this situation where you are now actually doing current temperature versus future. So you could have in Python a data model that predicts the temperatures and also predicts them based on the current temperatures. And then of course we've got 10D array. So what would you use 10D array? So here you could add an additional element such as the altitude. So what is the temperature at sea level? What is it? So you could do various altitudes to calculate the temperature, across different properties of the country or the city that you are measuring. So as you can see, this is where you would practically use, arrays moving from a simple 2D array, 3D array, all the way to, 5D array, 6D array, 7D array. So now you sort of understand why you would use that. So I hope you found this video useful. I always thought arrays are very confusing and people do not have an idea where would you use 7D array, where would you use 9D array. You can use these in any situation that you have. The more data you capture about something, the more dimensions it will have and the more ways you can actually view and twist that information to make it much more valuable. So this can be used in data science or data engineering, wherever your field is. So yeah, you definitely look into arrays in Python. They are so valuable. The Numpy module in Python allows you to generate random numbers. So you import the module in, and then what you can do is you can declare a variable, and then you can access the Numpy module as you do here. Numpy module in Python allows you to generate random numbers. So here, what you can do is access the random function here using Numpy random class and then random function here called rand, and then pass it how many random numbers you want. And what it will do is it will give you array back. So if I run this, what that code there, 5, will do, it'll give you an array of 5 random numbers between 0 and 1. And then if you wanted to get an array out of that, so a 2-dimensional array, so with rows and columns, then what you can basically do is say, I want a 3 by 3 grid. So this would give you then 1, 2, 3 here, and then 1, 2, 3 rows down. So think of it like an Excel spreadsheet going across 3 columns and going down the 3 rows here. And the dish type that the random function actually returns in NumPy is of numpy.nd array. So this is actually a multi-dimensional array that it returns. So I hope you found this useful. This is where you can use the random function to get an array, and you can continue to expand that from 2D array to 3D array if you wish. Did you know that you can generate random integer numbers in Python using the NumPy module and then using the randint function? There is a difference between rand and randint. Randint is much better in terms of syntax because what we're doing here is the syntax for this is saying that we want numbers between 5 and 15. Now notice I've kept 16 here because this is exclusive. So 16 is excluded from this number. Normally what you might find is some functions are inclusive, but mostly you would find in Python they are exclusive. So the number that you mentioned here is excluded. So you only get it from between 5 and 15. And then notice I'm using the size argument here, and the size is we want 3 by 3 grid. So if I run this, and you can see the difference between them, when you use the rand function, you get decimal numbers. You have to then use this calculation formula to get numbers between 5 and 15. So this is harder to understand. While with the randint, it's easier to understand. You can already see that you want numbers between 5 and 15. And the 3 by 3 is basically saying 3 columns across and 3 rows down. And here again we got that 3 by 3 array, and you can see 1, 2, 3, same output, but you get decimals. But with the randint you do not get decimals, so it's much more easier to use. Just make sure you use the randint to get random integer numbers between certain values and of certain grid size or table size that you want. NumPy array class has a very useful function called asType. This asType function basically lets you convert the array into any data type that you want. So here you can convert your array, which is a floating point decimal, into an int. So that will basically truncate the decimal point. So it won't round it, it will simply truncate it. Then you can convert an integer into a float type, and you can convert it to a string type. The last one is really useful. You can convert it into a Boolean. So if I run this, and you can see the very first one, all the decimals have been converted into integer just by using asType and then telling it what data type you want. But if you look at the second one, they've been converted into a floating point. And then here, if you look at this one, they've been converted into a string, but you can see these single quotation marks to indicate these are strings. And the last one, which is Boolean. So here, this is an interesting one. This is basically wherever you have a 0, that will be given a false value. Then where you have a number, that will be given a value of true. So as you can see, we had false, true, 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 and then a false because we had a 0 here, and then finally another true. So this might be useful in something whether you are trying to eliminate some data or some numbers, then you can convert your array into Boolean to quickly come up with an answer. So yes, just remember, as type function, which is available only in the Numpy module and is available only to the array class, which allows you to convert the array to another data type very quickly, and it will create a copy of the array, so emojing the existing array that you have. Did you know in Python you can find out the version of the Numpy module that you're using? So you can use the np__ version and then __ here, and you can also find out the file location of the version that you're using. So this will be useful when you've got multiple versions of a module installed in various different virtual environments. So here, if I run this, and as you can see, this is the version that I've got installed, and this is the file location where it's stored. So it gives you a quite clear indication of where to find it and version you're using in case you have any issues. So in terms of version numbering, this is how it works in Python. So it works using the semantic versioning, which is major, minor, patch. So the major part, so in our example, is 1, but this is significant changes that break compatibility. And then you've got the minor part, which is new features and improvements, but it doesn't break compatibility. And you have patch, which is bug fixes and minor correction. So here, as you can see here, we had this is the 4th version of the corrections, 26th version of improvements and optimizations, and this is the 1st version. So it doesn't break any compatibility issue there. So new features act this, which is the minor version, it doesn't break backward compatibility. But structural tree changes here. If it was a major version, then possibly you've got backward compatibility issue. I hope you found this useful. This is how you can query the version and the file that you're using.